Welcome to lecture 2 on integral calculus. In the first lecture, we discussed few problems on definite integral. In this lecture, we will do some more problems. So, first I will start with a few problems on definite integrals as the limit of sum. So, let me first explain the concepts of definite integrals as limits of sums. So, suppose we have a function f of x and we want to find the definite integral of f of x from a to b. So, what we know is that the definite integral gives the area under the graph of this function y equal to f x from a to b. Now, to evaluate this area, what we do is we subdivide this interval a b into n equal parts. So, let us call x naught is a, x 1 is a plus h, x 2 is a plus 2 h and so on, and x n is equal to a plus n h. So, this is my x naught, I have x 1, x 2 and the last one is x n. So, then what is h? N times h is x n minus x naught and this x n is equal to b. So, this is equal to b minus a. So, therefore, h is b minus a over n. So, this interval of length b minus a we are dividing into n equal parts. So, each is of length b minus a by n. Now, we can draw these rectangles and suppose I find the areas of these rectangles whose width is h and height is equal to this f of x I. So, what we have is this integral of a to b f of x dx is equal to limit as n tends to infinity of sum of these areas of the rectangles. So, what is area of rectangle? This will be h times f of a plus k h, where k is varying from 1 to n. This is same as limit n tends to infinity of summation k equal to 1 to n b minus a by n, this is h, times f of a plus k times b minus a by n. So, this is the formula for definite integral in terms of limit of sum of these areas. So, in particular, if a is 0 and b is 1, then we get integral 0 to 1 f x dx is equal to limit as n tends to infinity of summation k equal to 1 to n 1 by n times f of k by n. So, one thing you should note that here what we have done is in each subinterval we have taken the value of the function at the right end point and then we got these areas and we have added. We can also do instead of the right end point we can take the value at the left end point and do. So, we also have, if we take the values of the function at the left end points of each subinterval, instead of the right end points, we still get integral a to b f of x dx. So, we can write integral of a to b f x dx is equal to limit n tends to infinity and summation k equal to 0 to n minus 1 and the width is b minus a by n times f of a plus k times b minus a by n. So, instead of starting from k equal to 1 to n, if we start from k equal to 0 to n minus 1, this gives the integral. So, in some problems maybe you have to take this. In fact, one can take any point in the subinterval and that will still give the definite integral of f x from a to b. So, now let us start with some problems. So, question 1, suppose for a in R with mod a strictly bigger than 1, let limit of n tends to infinity 1 plus cube root of 2 plus cube root of 3 so on up to cube root of n divided by n to the power 7 by 3 times 1 by a n plus 1 square plus 1 by a n plus 2 squared up to 1 by a n plus n squared. This limit is given to be equal to 54. Then the possible values of a is or are, we are given 4 options. A is minus 9 or minus 6, C is 7 and D option is 8. So, if you see here we have limit of the ratio of two sums. So, we will try to write this as definite integral. So, what we do is we have limit n tends to infinity. In the numerator we have summation of r to the power 1 by 3 r equal to 1 to n, and in the denominator I have n to the 7 by 3 times summation 1 by a n plus r square r equal to 1 to n. Now, somehow, and this limit is we have to write as definite integral. So, what I will do is I will write this is equal to limit n tends to infinity. I write this as summation of r by n raised to power 1 by 3, then I have to multiply by n to the 1 by 3. So, this is the numerator, and in denominator I have n to the 7 by 3, and again I want to write as r by n. So, I will take n common from the denominator here. So, I have summation of r equal to 1 to n 1 by a plus r by n square, and then I will have n square in the denominator. So, I have 1 by n square. Now, if you see this n to the 1 by 3 is in the numerator, and I have n to the 7 by 3 divided by n square, that is again n to the 1 by 3. So, this cancels, and I have limit n tends to infinity of summation r by n to the 1 by 3 divided by limit n tends to infinity summation r equal to 1 to n of 1 by a plus r by n square. Now, this can easily be written as the first one is the integral from 0 to 1 of x to the 1 by 3 dx, because if we take f x equal to x to the 1 by 3 and then use this formula integral 0 to 1 f x dx is limit of 1 by n times summation f k by n, we get this. So, this I can also write as limit of n tends to infinity of 1 by n times summation r by n to the 1 by 3 and the denominator is again 1 by n times summation 1 by a plus r by n square. So, now the numerator becomes the integral of x to the 1 by 3 from 0 to 1, and the denominator is integral from 0 to 1 of 1 by a plus x square. This can easily be evaluated. So, this will give 3 by 4 x to the 4 by 3 from 0 to 1 divided by minus 1 by a plus x from 0 to 1. So, this is equal to 3 by 4 a times a plus 1 simplification. Now, this limit was given to be equal to 54. So, 3 by 4 a times a plus 1 is equal to 54. This implies a square plus a is equal to 72, which implies a square plus a minus 72 is equal to 0, and this gives a minus 8 times a plus 9 equal to 0. So, a is either 8 or minus 9. So, among the options given, we see that a equal to minus 9 and 8 are possible, but minus 6 and 7, these are not possible. So, this finishes problem 1. Let us move to question number 2. So, question 2 says, for every natural number n, we have y n equal to 1 by n times n plus 1 times n plus 2, product of these up to n plus n whole raised to power 1 by n, and if limit of y n as n tends to infinity is equal to L, then the value of greatest integer of L equal to what? So, we are given y n is equal to 1 by n times n plus 1 n plus 2 up to n plus n whole raised to power 1 by n. So, if I take this n inside, then this will be equal to n plus 1 by n times n plus 2 by n up to n plus n by n raised to power 1 by n, which is same as 1 plus 1 by n into 1 plus 2 by n up to 1 plus n by n raised to power 1 by n. So, here instead of sum, this is product of some terms. So, naturally we can take natural log. So, this implies natural log of y n will be equal to 1 by n times summation of log of 1 plus k by n, k is equal to 1 to n. So, now we can see that we have got this is equal to 1 by n times summation of some f of k by n. So, this implies limit of n tends to infinity of log y n is equal to limit n tends to infinity of summation of 1 by n times log 1 plus k by n, which is equal to integral of 0 to 1 of log of 1 plus x dx. This we can easily evaluate. So, we can integrate by parts here. This is equal to x times log 1 plus x from 0 to 1 minus integral 0 to 1 of x by 1 plus x dx. This is integrating by parts. So, this is equal to, at x equal to 1 we get log 2 minus at x equal to 0, this is 0, minus this integral, again I can do easily, this is equal to 1 minus 1 by 1 plus x dx. So, this is equal to log 2 minus x minus log of 1 plus x from 0 to 1. This gives log 2 minus 1 minus log 2, and at 0 it is 0. So, this gives 2 natural log of 2 minus 1, which is equal to natural log of 4 minus 1 I can write as natural log of e. So, this is equal to log of 4 by e. So, what we have got is that the limit of natural log of y n is equal to this. So, limit of natural log of y n is equal to natural log of 4 by e. Taking exponential, we get limit of y n is equal to 4 by e, and this was denoted by L. So, L is equal to 4 by e. What we have to find is the greatest integer of L. So, since we know that e is between 2 and 3, e is approximately 2.71. So, it is between 2 and 3. So, 4 by e will be between 4 by 3 and 4 by 2, which is 2. So, it is strictly between 1 and 2. This implies greatest integer of L is equal to 1. So, this is the answer to the second problem. Let us move to question number 3. So, here we are given f x is equal to limit as n tends to infinity of n to the n times x plus n times x plus n by 2 up to x plus n by n divided by n factorial times x square plus n square times x square plus n square by 4 up to x square plus n square by n square. This whole raised to power x by n. So, f x is given to be this limit for x bigger than 0, then which of the following options are correct? Option A is f of half is bigger than equal to f of 1. Option B is f of 1 by 3 is less than equal to f of 2 by 3. C is f prime of 2 is less than equal to 0, and D is f prime of 3 divided by f of 3 is greater than equal to f prime of 2 divided by f of 2. So, first we have to somehow simplify this limit. So, first let us look at this term. We have n to the n times x plus n by 2 up to x plus n by n divided by n factorial, and then we have x square plus n square, x square plus n square by 2 square up to x square plus n square by n square, and this is raised to power x by n. So, let us first simplify this ratio. So, here we can write this as, if I take n common from the first factor, then this is equal to n times 1 plus x by n, and then I will take n by 2 common from the second factor, then this will become 1 plus 2 x by n, and so on. From the last one I will take n by n common, then it will become 1 plus n x by n. And similarly, from the denominator we have n factorial. Now, take n square common from the first one, then it will become 1 plus x square by n square, and n square by 2 square common from the second one, then it will be 1 plus 2 square x square by n square, and so on, n square by n square times 1 plus n square x square by n square. Now, if you see, in the numerator I have 1 n to the n, and then we have n times n times n times. So, that will again become n to the n. So, I have n to the 2 n times 1 plus x by n, 1 plus 2 x by n up to 1 plus n x by n, and we have 1 times 2 times 3 up to n. So, this is this divided by n factorial. This is the numerator, and in the denominator we had 1 n factorial, and we have n square multiplied n times. So, that will become n to the power 2 n, and in the denominator I have here 1 square, 2 square, 3 square up to n square. So, that is n factorial squared, and then we have this product 1 by x square by n square, 1 plus 2 square x square by n square, all the way up to 1 plus n square x square by n square. Now, if you see, this n to the 2 n cancels, and I have here 1 by n factorial in the numerator. Here I have n factorial by n factorial square. So, again this cancels. So, we are just left with this product in the numerator divided by this product. So, what we have, so therefore, f x is equal to, now I will write limit n tends to infinity of 1 plus x by n, 1 plus 2 x by n up to 1 plus n x by n divided by 1 plus x by n square, 1 plus 2 x by n square up to 1 plus n x by n square, and this whole raised to power x by n. So, now just like the previous problem, we can take natural log. This implies log of f x is equal to limit n tends to infinity x by n times log of this. So, that will be equal to summation log 1 plus k x by n, k equal to 1 to n, minus summation log 1 plus k x by n square. So, this is because log is a continuous function. So, log of this limit I can write as limit of the log, and we get this. Now, this is equal to limit n tends to infinity x by n times summation log 1 plus k x by n. This is one limit minus limit n tends to infinity x by n times summation k equal to 1 to n log of 1 plus k x by n square. So, now again this limit of sum can be written as the integral. The first one will be integral from 0 to x of log of 1 plus y dy. Why is this? Because say if you see for k equal to 1, I have x by n, and for k equal to n, this will become k times x by n. For k equal to n, it becomes x. So, this the lower limit is 0 and the upper limit is x, and the function we are taking log of 1 plus y, and the second limit is equal to integral from 0 to x of log of 1 plus y square dy. Note that here in the integrand we should not write f of x, because x is already here. So, we have used another variable y here and we write like this. So, this gives me log of f x equal to integral from 0 to x of, I can write log of 1 plus y divided by 1 plus y square dy. Of course, we should not try to evaluate this integral, because the second integral is not easy to evaluate. So, now we should look at the options and try to see what we can deduce. So, if we see options A and B, we have to compare f of half with f of 1 and f of 1 by 3 with f of 2 by 3. So, if we can calculate the derivative, we can see whether the function is increasing or decreasing, and then we can deduce this. So, that is easy to do here. So, we differentiate this, differentiating with respect to x, we get so log of f x. If we differentiate, we will get f prime x by f x equal to, this is integral 0 to x of f of y dy. If I differentiate by fundamental theorem of calculus, this will simply give log of 1 plus x by 1 plus x square, and we always had x bigger than 0. So, we get this as f prime x by f x. So, this implies f prime x is equal to f x times log of 1 plus x by 1 plus x square. Note that f x is clearly positive, because f x was, if x is positive, then this term is positive for every n. So, f x is positive, and what about log of 1 plus x by 1 plus x square? So, and log of 1 plus x by 1 plus x square, this is positive if x is between 0 and 1, because if x is less than 1, then 1 plus x will be bigger than 1 plus x square. For x between 0 and 1, x square is smaller than x. So, this ratio 1 plus x by 1 plus x square, this is bigger than 1, and log of anything bigger than 1 is positive. But if x is bigger than 1, then the denominator has x square, this is bigger than x. So, this ratio 1 plus x by 1 plus x square becomes less than 1. So, this becomes less than 0 if x is greater than 1. So, therefore, f dash x is greater than 0 if x is between 0 and 1, and this is less than 0 if x is bigger than 1. So, what does this tell us? So, this implies f is an increasing function on the interval 0 to 1, and it is decreasing function on 1 to infinity. So, if we see the options, f of half and f of 1, between 0 and 1 f is increasing. So, f of half will be less than f of 1. This implies f of half has to be less than f of 1, and f of 1 by 3 will be less than f of 2 by 3. So, option A is incorrect, but B is correct. Now, C and D options, C asks for f prime 2 and D is comparing f prime 3 by f 3 with f prime 2 by f 2. So, these again we can get from what we have calculated. So, let us see what is f prime 2. F prime 2 will be equal to f of 2 times log of 1 plus 2 by 1 plus 2 square. This is equal to f of 2 times log of 3 by 5. So, f of 2 is positive and log 3 by 5 is negative. So, this will be less than 0. So, option C says f prime 2 less than equal to 0. We know that f prime 2 is less than 0. So, C option is correct. And what about D option? We have to see f prime 3 by f 3 and f prime 2 by f 2. So, we have f prime x by f x is equal to log of 1 plus x by 1 plus x square. Therefore, f prime 3 by f 3 is equal to log of 4 by 10, which is log of 2 by 5, f prime 2 by f 2, this we have already calculated, is log of 3 by 5. So, log is strictly increasing function. So, log 2 by 5 is less than log 3 by 5. So, this implies f prime 3 by f 3 is strictly less than f prime 2 by f 2. So, our option D, that means, is wrong. We have the other inequality. So, B and C are correct option. Okay, let us move to question number 4. So, let f x is equal to integral from 1 by x to x of e to the power minus t plus 1 by t divided by t dt for x in 0 to infinity, then which of the following options are correct? F is increasing on 1 infinity, B f is decreasing on the interval 0 to 1, C f of x plus f of 1 by x, this is equal to 0 for all x in 0 to infinity, and D option is f of 2 to the power x is an odd function of x on R. So, here we are given f x as a definite integral, and then we have to find these options. So, because we are being asked for increasing and decreasing, we can calculate the derivative of this function to see whether f is increasing or decreasing in some interval. So, let us recall if we take the derivative of some f t dt from some function a x to b x, then what is this? So, this is equal to, we evaluate f at the upper end point b of x and then multiply by the derivative b prime x minus f of a x times a prime x. Right. So, this is the general formula for derivative of definite integral, where the limits of the integrals are functions of x. Right. In particular, when we have integral from a to x, then we simply get f of x, but here f we have to evaluate at the upper end point times the derivative of the upper one minus f at the lower end point times the derivative of that. So, we have f x as 1 by x to x e to the minus t plus 1 by t divided by t dt. So, if I differentiate this, then f prime x will be equal to e to the power, first we put t equal to x in the integrand. So, that is x plus 1 by x times the derivative of x, which is 1, minus we have to put t equal to 1 by x. So, e to the minus 1 by x plus 1 by t will become x divided by t is 1 by x times the derivative of 1 by x will give minus 1 by x square. So, this is nothing but 2 times e to the minus x plus 1 by x divided by x, and because exponential is always positive, this is greater than 0 for all x bigger than 0. So, this implies that f is strictly increasing on the interval 0 to infinity. So, f is an increasing function on the whole 0 to infinity. So, therefore, option A is correct and B is wrong. Note that we could have also deduced this same thing without calculating the derivative of this function, because let me write another way. We see that the interval 1 by x to x, this increases as x increases. Why is this? Because as x increases, the lower end point 1 by x will decrease and the upper end point x increases. So, therefore, as x increases, the interval becomes bigger and bigger. Also, the integrand is positive, because integrand is exponential divided by t. For t positive, this is always positive. So, if we have a positive function, then if we integrate it on a bigger interval, this will be bigger. So, therefore, f x is an increasing function. Right. So, even without calculating the derivative, one can easily see this by just seeing that the interval on which we are integrating this positive function is becoming bigger as x increases. Now, to see option C and D, we have to look at f of x plus f of 1 by x. So, let us see what is f of 1 by x. F of 1 by x will be integral from x to 1 by x of e to the minus t plus 1 by t dt. We put t is equal to 1 by y, then dt is minus 1 by y square dy, and when t is equal to x, y is 1 by x, and when t equal to 1 by x, y is x. So, this f of 1 by x will be equal to integral from 1 by x to x of e to the minus t is 1 by y. So, 1 by y plus 1 by t will be y divided by t is 1 by y and dt is minus 1 by y square dy. This is same as 1 by x to x, we have a minus sign and then we have e to the minus y plus 1 by y divided by y dy, which is same thing as minus f of x. So, this implies f of x plus f of 1 by x, this is always 0. So, f of x plus f of 1 by x equal to 0, this is option C is correct. Now, what about option D? This follows from option C. So, now also if we write g x equal to f of 2 to the x, then g of minus x is f of 2 to the power minus x, which is equal to f of 1 by 2 to the x, and we know that f of 1 by x is equal to minus f of x. So, this is minus f of 2 to the x, which is equal to minus g x. So, this implies g x is an odd function. So, that gives option D is also correct. So, option A, C and D are correct options. All right. So, this finishes lecture 2 on integral calculus. In the next lecture, we will discuss some more problems. Thank you.